Hello everyone, welcome to the Cisco Certified Network Associate Training Program by Learnedze Network. My name is Kosi Gosami, your trainer for this CCNA training program. Today, in this video, we are going to discuss about the switch, a Cisco switch. Here, basically, we are going to cover these topics, especially how a switch work, what are the basic functionality of a switch, how the layer 2 and the multi-layer switches work, what is VLAN, how we can create and configure VLAN, what is DTP and what is VTP. So let's start. So as we know that switches are more intelligent than a hub. Why it is intelligent? Because we know that a switch can store the MAC address of the devices or the host that is connected into the ports of the that is directly connected into the ports of the switch. So it has that ASIC application specific integration security features where it can stores the MAC address of a switch of the devices of the host that is connected. So for a switch it is more easier to transmit, or it is more easier to pass the data from host to the network, or from the network to the host, or from the host to host. So it can process the data very fastly. It has only one broadcast domain. What is a broadcast domain? That if I connected internet from any of the port of the switch, then all the other ports will automatically got the internet. So that is also one of the features, that it has a broadcast domain, but it also has some disadvantages also. We'll going to discuss throughout this video, in this video session. Okay, but before, let's see what is a MAC address and how a switch can learn a MAC address. Okay, for that let's open our packet tracer tool. Okay, so let's take a scenario where there is a switch, 24 port switch. Okay, you can see the physical view of the switch. This is exactly how the Cisco switch, the back panel is look like. There is a 24 port, as you can see over here. There is a power cable, power adapter, and this is a console port to program this switch. So as you can see that I have connected 4 PC to the 4 port of a switch. FA0/1, this PC is connected. FA0/2, 192.168.0.4 IP address, PC is connected. FA0/3 and similarly FA0/4. All these PCs are connected, directly connected to the switch. Now let's go to the switch. Let's open the CLI and let's check whether this switch has. Now let's check whether this switch has uh, any MAC address information right now or not, because we have just connected this host and devices, right? So let's check. Let's enter the command show MAC address table. Okay, as you can see that there is no MAC address information available with the switch. So initially the switch has no idea that which device is connected to the this switch. So let's check this out. Let's check first in the simulation environment. Okay, in the real-time environment we are going to get to know about that how a switch can discover the physical addresses or MAC addresses of a device. We're gonna figure it out, but let's just understand in a simulation environment so that we will understand this better. Okay, so let's just take one message. Okay, let's take this message from here. Okay, then what I am trying to do is that I am going to transmit one message from this blue laptop to this green laptop. Okay, so I'll click here one message, then click here. As you can see that here this is in progress. Okay, so let's start its simulation and check this out, that what is happening actually. Okay, see, this PC is sending one message request to the switch. Now the switch has sent a broadcast ARP request to all the switch, so that it can discover the MAC address information. This other two PC, you can check that this other two PC number, this 192.168.0.3 and 0.5, they have cancelled out that ARP broadcast request. They told me that no, this message is not for us. Okay, this message is only for this PC. Okay, so as you can see this packet details over here, you can, let's check this out. Okay, so what the switch has done, initially it has sent a ICMP request, ICMP packet from 0.4, but switch has no idea where to send it, where the 192.168.0.2 is available. So that's why what switch has done, switch has just randomly throw some ARP, one ARP ARP broadcast request. What is ARP broadcast request? ARP means address resolution protocol. Okay, to find out the layer 2 information, or you can say make address information, a switch broadcast an ARP request to all over his host. Okay, so that from that ARP broadcast request, this 192.168.0.3 and 0.5, these two PC has told that no, this request is not for us. Okay, but 192.168.0.2 has respond to it, and it says that yes, this message is this request is for us, for me, and here's my MAC address. So it sent the MAC address information to the switch, and similarly the switch has maintained its database and it has recorded the MAC address information of this PC 192.168.0.2 that is connected in the port 0/4, and also it has a source F0/2 MAC address information. As we can check it also. Let's go to the switch. Okay, again now let's try the similar command, show MAC address table. Okay, you can see that we have now two PC information in our MAC address. One is which is connected in the F0/2. Okay, here MAC address is this one, and another is FA0/4, which MAC address is this one. Okay, you can check. Okay, so how you can check, you can just move the mouse cursor in front of the device. You can check that this is the MAC address and it is available in the switch MAC table also. So what happens in the switch, that switch can easily store the data of each and every device connected to it. So next time if I want to send data from this laptop to this laptop, okay, then it will don't take much time. It will don't, because it already has the information of these devices. So let's try by sending one message from this PC to this PC. So it will be, let's check the simulation. It will send next, this time this switch know that this is the device, so it is not sending any ARP broadcast request. Okay, it is directly transferring the messages, so no packet losses occur and the communication is happen smoothly. So that's why we call that switch is a intelligent device. So MAC address is 48 bits long. Out of 24-bit is OUI, that is organizationally unique identifier, that is maintained by IEEE. So from this first 24 bits you can just assume that which manufacturing which manufacturer is manufacturing the devices. Okay, it can be Cisco, it can be HP, it can be like uh, other manufacturing companies like Dell and all. Okay, whatever, suppose if you have a PC which is manufactured by HP or maybe Lenovo or maybe any vendor. Okay, so that manufacturer identifying is that was given by IEEE is given by this first 24 bits, and next 24 bits is assigned by the vendor. Now let's see where we implement the layer 2 and layer 3 switches in an enterprise LAN architecture, or we can say that in our offices, or maybe if we have a LAN setup over in our home or building, small building, there in the network design, in the campus distribution design, we can use the layer 2 and layer 3 switches as shown in the slides, just like the shown in the slides, because like uh, in the layer 2 switches they can process the data very fast way by based on the MAC addresses available in their MAC table. Okay, that MAC table is, we can say that it can be called as a CAM table also. It has the information of MAC address, which whatever the devices that is connected on the port. Besides this, there are layer 3 switches also, which we often use in like campus distribution edge. Here in the layer 3 switches, basically besides it works on the layer 3, or you can say that it works in the network layer. So besides having the switch information, that is MAC address information, or you can say CAM table information, it also has like forward information base, FIB, forwarding information base, also here. So in the layer 3 switches, what we can do, we can put some routing protocols also over there. Okay, so it works on the layer 3. It has capability of forwarding based on the IP address and routing information that is available over here. So suppose uh, we have a campus here, we can use routers, and we can use layer 3 switches also for connecting different networks. But if we use that layer 3 switches, then the data process will be in a faster way. Okay, when it comes to a switch, there is an that disadvantage that I have already discussed in the previous slides, that there is one disadvantage that is called that one broadcasting domain. So like what happened, uh, when we connected, let's check let's check in the packet tracer. Okay, let's take one switch. Okay, let's go to the physical view of the switch. So as we can see here, this is 24 ports are available over here. So what is the most disadvantages of a switch is that if I connect one Ethernet cable in the port 1, okay, and that Ethernet cable carries the internet, or you can say that gateway. Okay, the gateway to the internet is connected to that port 1. Okay, then what the other port on the switch are in that broadcasting domain only. So if I connect one internet cable over here, then rest of the ports will automatically got the internet or the gateway address. So this is one of the most disadvantages of the switch. Suppose we have two different network or two different gateway. Okay, so in that scenario we cannot use a single switch, right? So here in some scenario, like we might waste most of the ports of a switch. Suppose we have a, right here we have a 24 port switch, and this switch is installed in a uh, lab where 12 PCs have one another gateway, and rest of the 12 PCs have different gateways. So in that case we cannot use this switch because it has one broadcasting domain, so it has a physical limitation. So to overcome this limitation, what we will do, we the VLAN concept has come. What is a VLAN? VLAN is nothing but a virtual local area network. It is not physical, it's virtually configured in the software. So here we're gonna see that how a VLAN can be created, how a VLAN can be configured on a switch, and how a VLAN work. Okay, so as you can see here in the picture, that we have three different switches over here. Okay, so let's say we have the three floor of a building, floor 1, 2 and 3. Okay, and three switches on each of the floor. Okay, and each of the floor we have three different PCs, or you can say server on the third floor, and rest of the floor have three different PCs, where each PC are assigned to different department. Suppose this PC, as you can see, this is assigned to the engineering department, this is assigned to the marketing department, and this is assigned to the accounting department. And what is the requirement is that whatever the PCs and server or devices that used by engineering department, it should not be accessible by other departments, that is marketing or accounting department. Suppose let's take a scenario, this is in the third floor, accounting department has a printer. So this printer can only be like accessible by or shared into the PCs of the accounting department only, those who are working with the accounting department also only. So this printer we don't want to share with the marketing VLAN and engineering VLAN. How we can achieve that? We can achieve this scenario, this problem, by what we can do, we can configure that three different network, right? But in that scenario we need routers, multiple routers. Since routers are costly device, so it will not be a reliable solution. So in that case the VLAN concept comes. So if we create three different VLANs and we assign to the ports, okay, then what we can achieve, we can achieve this different department accessibility. Like somehow logically, if we can divide the ports of this switch, so that all the ports, like the specific ports specified to a particular department, then we will achieve this case of scenario. Okay, so basically what happened in VLAN, whatever the physical ports we are having, we divide these physical ports in a logical way. So this is called VLAN actually. In a VLAN we divide the physical port of a switch in a logical way. Okay, let's check this on the Cisco packet tracer. Suppose we have a switch here, okay, and we have around 24 ports available over here. So we cannot divide these ports. We cannot say that this 12 will act in a different department and this rest of the 12 will act in a different department. Okay, so in that scenario what we can do, we can create some VLAN, virtual LANs, and we can assign these ports. Suppose we have created one VLAN called engineering, okay, then we have assigned these ports to that engineering department. And suppose this have like sales department, okay, and these 12 ports we assign to the VLAN cells. Okay, so in that scenario we can logically divide this switch. Okay, so let's take one switch. Okay, here I am going to take 3 PC for engineering department and 3 laptop, let's say for uh, marketing department. Okay, so let's connect this. Since we are connecting different devices, so it will be a straight line, straight cable. Okay, so let's connect each of the PC by using straight cable. Okay, okay, so let's assign the IP address to each of the PC. Okay, let's say 10.0.0.1. Okay, let's assign this on this PC1. Here this one is 10.0.0.2. Okay, let's assign this on PC2. This one is 10.0.0.3. Let's assign this. Let's take this 10.0.0.4, 5 and 6. Okay, so we have assigned the IP addresses. Okay, so now let's check the connection, whether the connection is okay or not. Now let's go to this PC, then CMD. Let's try pinging 10.0.0.6. Okay, yeah, so you can see that from this PC to this PC connection is okay. That means all the connections are okay. Okay, so what is our main aim? Aim is to make these 3 PC on the engineering VLAN and rest of the 3 PC to the suppose sales VLAN. Okay, that means let's see engineering and this one is sales. Okay, so as you can see right now, the all the PCs have proper communication with each other. Okay, this PC can connect to this PC, this PC. Okay, but what I want, what we can do by using VLAN, we can do is that we can logically divide the switch. Now physically this all become in one broadcast domain. Okay, but why we want to control that? We want to control that these 3 laptops has to be in the separate VLAN and this 3 PC has to be in the separate VLAN. That means these have a separate broadcast domain and this has a separate broadcast domain, and for that let's go to the PC and create some VLAN. Okay, VLAN and assign these ports to the VLAN. Okay, but before that But before that, let's see what is the current VLAN status right now. Okay, for that you have to enter the command show VLAN. Okay, so as you can see here, by default VLAN 1 name is default and this port are connected. That means by default all the physical ports, that is FA0/1 to 0/24 and 2 gigabit Ethernet port, okay, all these ports are connected to VLAN 1. That means by default all the ports are on VLAN 1. Okay, then this 1002 is called FDDI default. Okay, this one is okay. So rest of the VLAN, as we can see, is mentioned over here. Okay, we'll discuss about this later. Okay, but before that, let's configure two separate VLAN, create two separate VLAN and assign those ports. Okay, so for that, let's go to the configure terminal. Okay, so I'm doing it on a shortcut, so that's why I had written config t. Okay, so here first we are going to create two separate VLAN. Okay, for that let's write down VLAN 10. Okay, then what is the name of the VLAN is, let's say, engineering. Okay, next write down VLAN 20. Okay, then name will be, let's say, sales. Okay, now let's just check whether we have created the VLAN. So for that, let's write down show VLAN. Okay, as you can see, we have created two separate VLAN, that is VLAN 10 called engineering and VLAN 20 called sale. Okay, now what will be our next step? Next step will be that these three laptops we are going to assign VLAN 20, that is sales. Okay, and these three PC we are going to assign to the VLAN 10, which is called engineering. Okay, for that let's go to the again configuration mode, that is global configuration mode. Okay, so let's write switch port access VLAN 10. Okay, now we have assigned from switch port FA0/1 to 0/3 to VLAN 10. So this is the command. Okay, next we'll go to the interface. Okay, interface range, you can say interface range FA0/ the next laptop has connected to the FA0/4, right? 4 5 6. Okay, so 0/4 to 6. Okay, here let's write down again the same command, switch port access VLAN 20. Okay, so let's again exit. Okay, here now we are going to check whether this all whether we are achieving our goal or not. Okay, for that let's write so VLAN, you can write down brief also, so VLAN brief to show the VLAN database, right? So as we can see over here, okay, the port number FA0/1 0/2 0/3 has gone from the VLAN 1 default VLAN and it is assigned to VLAN 10. Okay, you can see, check here, In VLAN 20, FA0/4, 5 and 6 had assigned. That means these three are in separate VLAN, because as you can see FA0/6 is this one and this one is FA0/4, right? Okay, similarly FA0/1 is this one, okay, FA0/2, FA0/3. So these three are in separate VLAN. Now let's try to ping from this PC, second PC, to the fifth PC, this one. Okay, let's go, write down ping, write down 10.0.0.5. okay, so as you can see, all the packet will get lost over here because both the PCs are in separate VLAN. So as you can see, all the packets are getting lost because that 10.0.0.5 in the separate VLAN. That means we have successfully divided the switch logically into two broadcast domain. Okay, but let's check once inside the that's VLAN engineering domain. Okay, engineering VLAN. Okay, here this 10.0.0.1, 0.2 and 0.33 pieces are here. Okay, currently I am on 10.0.0.2, so let's ping to the 10.0.0.1. We're gonna check whether this connection is okay or not, whether this tree is in one broadcast domain or not. Okay, let's enter, let's ping. As you can see that these three are in this is successful, or these three are in same VLAN. Okay, so what we have done, we have logically divided the switch into two parts. One is called engineering VLAN, another is called sales VLAN. So this is the VLAN where we have like overcome the limitations of a switch by logically dividing the switch. Okay, so now let's remove the VLAN. Okay, let's remove the VLAN. So how we can remove the VLAN? So as we have already know that to remove something in the Cisco, we have to write down the negate command, that is no. Okay, so let's go to the interface range FA0/123. Okay, then write down no switch port access VLAN 10. Okay, so I have removed this command, then exit, then again let's go to the interface range, which one, FA0/4 to 6. Okay, here write down no switch port access VLAN 20. Okay, now let's go to the end and now let's check the VLAN. So VLAN brief. Okay, so as you can see, we have successfully removed the ports from the 10, that is engineering VLAN and sales VLAN. Okay, now we are in the initial stage again. Okay, and you can see in the VLAN 1, that is default VLAN 1, all the ports, that is FA0/1 to 6 had come. Earlier you can, when we are checking, FA0/1 to 0/6 is indeed these two VLAN, and from default VLAN it has removed. Okay, but now all the ports are in the default VLAN. That means we have successfully removed the VLAN. Okay, now we can ping. Now let's go to the PC3. Okay, write down again, check whether it is pinging or not. See, you can check that it is pinging. Okay, let's go to the PC2. Okay, let's check whether this time it can ping to the 0.5 or not. See, the communication is happening. Okay, so this is basically about VLAN, how to remove VLAN. Okay, now let's move to the VTP. Okay, VTP is VLAN trunking protocol. As you can see that VTP is a VLAN trunking protocol. Why we use that? We use to create a trunk between the switches. Okay, why? Let's check out in the uh, this Cisco packet tracer. Let's take this scenario where there are two switches. This is one is switch 1 and this one is switch 2. Okay, in switch 1 we have created VLAN of 3 PC, VLAN 10 engineering, and VLAN 20 of 3 laptops, where VLAN 20 this is called sales. Similarly in switch 2 also there are engineering VLAN and sales VLAN. Okay, what I want to do is right now I want to communicate this engineering VLAN from switch 1 to switch 2. Let's check it out whether the communication happens or not. Okay, we have just simply configured the VLAN. Okay, let's ping to, let's say, 10.0.0.7. Let's check this out. So as you can see, all the packets are lost, 100% lost. So that means although they are in the same VLAN, although we haven't used any routers and all, although we are communicating through switch, but this VLAN information is not available in this switch. That means both of the switch haven't interchanged their VLAN information. So why? Because we have simply connected these two switches by using this cable. Okay, by using this crossover cable. Okay, so now what we have to do, we have to create this crossover cable as a trunk between these two switches. Once we declare them as as a trunk, then all the VLAN information from switch 1 can be accessible from switch 2. Okay, so let's go to switch 1 and declare them as a trunk. Okay, let's go to switch 1. Let's go to the configuration terminal. Okay, here let's go to the interface where the other switch has connected. So interface FA0/7. Okay, so here what I'll gonna do, switch port mode, switch port mode. What are the mode available? One is access, one is dynamic, one is trunk. Access is when there is no conditions is available. Okay, so when someone want to access. Okay, trunk is when we set as a trunk, and dynamic is when we don't know that what is the next configuration, like we have when we have many switches. Okay, we are going to discuss about this dynamic. Okay, what we can do, we can do by access also the same thing, DTP, sorry, trunk and access. Okay, so we are going to configure the as a trunk. Okay, so that's why we are going to use this command, switch port mode trunk. Okay, now this port 7 I am configuring as a trunk. Similarly, come to the switch 2. Okay, here let's say configuration terminal interface F0/5, right? Here let's write switch port mode Okay, switchboard mode trunk. Okay, write down again. We are on the interface, right? Switchboard mode trunk. Okay, so as you can see, we have configured this as a switchboard trunk. So this is called VTP, VLAN trunking protocol. Okay, you can use switchboard mode access also to access this. Okay, so now let's check out whether this PC can access this PC or not. Okay, let's go to the 10.0.0.1 on the terminal. Let's try to communicate 10.0.0.7. Okay, see, now this can communicate easily with a 0% loss. Okay, let's check out this VLAN also. Okay, let's click on this PC. Let's write down ping 10.0.0.10. Okay, this one is sales. So you can see that sales also can communicate with the sales easily. Okay, but when there are many switches in the network, okay, so we cannot assign each and every like if every time a new switches will come, will connect to the network. Okay, then every time we will have to assign them as a trunk mode. Okay, then and there are lots of security issues also when we configure this as a trunk mode. Okay, so we're gonna discuss this later, but uh, before that, like when we can like when we want to expand our network, then DTP, dynamic trunking protocol, is mostly used. So we have to know about dynamic trunking protocol, and for that let's configure this. Okay, so let's go to this. Let's move back to the slides first. Okay, so as you can see that VTP is a Cisco proprietary protocol. This is for Cisco devices only. Okay, so we have discussed about the VTP, how the VTP can be configured. As you can see that switch 1, switch 2, switch 3, switch 4 all are sharing its VLAN databases only because when we have created as a trunk. Okay, there are VTP modes. Okay, then VTP server mode, client mode, transparent mode, and off mode. What are these modes? Okay, let's go back to the previous slide. As you can see, we have four switches over here. Okay, in the four switches, all suppose every time the trunk shares is VLAN database information. Okay, it's it's sending the VLAN database information to its neighbor switch, then it is also sending to its neighbor switch. Okay, so it will be a unnecessary data packet flow, data frame flow of frames. Okay, so in that case, what we can do, we can configure the switch as a server mode, so that only the server switch can send the VLAN database or all the VLAN information. That is, suppose we have connected a new VLAN, if I assign a new switch where new VLAN databases are there. Okay, then this VLAN information will come to the come to the that switch which is configured as a VTP server mode. Okay, client will be client behave the same way as the VTP servers, but what in the VTP's client we cannot create, change or delete the VLAN. Okay, so client will behave like a client, as we have know that client server model, right? So similarly same model we are going to apply over here in this VTP mode, so that less communication and the VLAN, like the trunk trunk uplink will become faster. For that we are going to use this server client model and transparent. We are going to see right now. Okay, transparent means the switch which will not participate in this scenario, that will act as a VTP transparent mode switch. Okay, so let's go to the packet tracer tool again. Here, let's check out first which VTP mode is this switch in. This both switch are. Okay, let's click on the switch one. Okay, here let's write down so VTP status. Okay, this command is used to know about the VTP. As you can see that VTP version 1 to 2. Okay, there are two versions. VTP capable of. Okay, then VTP pruning we're going to discuss in this video. Okay, then domain name, we can create domain name also over here. Okay, okay, here is the status. VTP operating mode is server. Okay, so this switch is in VTP server mode. Let's check out the switch 2. Okay, let's check. So VTP VTP status. Okay, as you can see that this VTP is also in the server mode. That means we can say that by default all the switches are in server mode. So what we can do, we can, since we have only two switches in our network. Okay, then I'll configure this switch one as a server mode, which is already is. Okay, and I'll sense the mode of this switch to client mode. Okay, to sense, let's go to the switch, let's go to the configuration terminal. Okay, then let's configure that VTP mode. Okay, so VTP mode client. Okay, so when we use this command VTP mode client, the setting device to VTP client mode. That means this switch is now acting as a client. Okay, what we can do, we can make it as a server, as a transparent, as our wish. Okay, so we are making this as a client. Now let's check out the VTP database. Okay, so VTP status. As you can see that now this is operating in a client mode. So in a large network, what we can do, we can make one switch as a server where we are going to create VLANs. Okay, accordingly our use. Okay, we can create, we can delete. If there is no need of a VLAN, then we are going to create, delete the VLAN. Okay, and all the information will going to exchange from that server, VTP server mode switch. Okay, and the client will act as a client, and if we need, like those who don't want to, like those switches which are not necessarily need to participate in it, in this VTP phenomena, they will just pass out whatever the VLAN databases they will get, they will just pass out. So pass out to the its neighbor switches. Okay, so in that scenario, what we're gonna do, we are going to configure that switch as a VTP transparent mode. Okay, so these are basically the modes of VTP modes. These are okay. Besides this, there is a VTP off mode also. We can turn off the VTP. Okay, then how we can turn off the VTP? By using the negate command, no command. Okay, so we have seen how to configure the VTP. Okay, and what are the different modes of a VTP, like server mode, client mode, transparent mode. Okay, now it's time for DTP, dynamic trunking protocol. Okay, so as you can see in the slide, if two switches are capable together, they can negotiate a trunk connecting using Cisco's DTP command, that is dynamic trunking protocol. Okay, so here two command we basically use. One is switchport mode dynamic auto, and another is switchport mode dynamic desirable. That means automatic means when we configure a switch in switch port dynamic auto mode. Dynamic auto, that means it is in automatic mode, that it can form a dynamic trunk or cannot. It depends on the neighbor switch configuration. If the neighbor is also in the auto mode, then it will uh, form the dynamic that trunk. Okay, switch port mode dynamic desirable means it is willing to form a desirable means initially the trunking with the other side trunk, if the other side is set to dynamic auto, dynamic disable all trunk, that means it will create a dynamic trunk, it will create a trunk. Okay, it is desirable to create a trunk even if the neighbor switch is on dynamic desirable or dynamic auto. Okay, so it will create a trunk. Let's check this out how the DTPs can work. Okay, so let's go to the switch 1. Let's go to the configuration terminal. Okay, let's go to the interface FA0/7. Here let's say switch port no switch port mode trunk. Okay, so I am removing the trunk first from the both of the switch. Okay, let's go to the switch 2. Let's go configuration terminal, then no. Let's go to the interface FA0/5. Let's configure no switch port mode trunk. Okay, so I'm removing the trunk. As you can see, they become yellow, so the trunk I have removed. Okay, now what I am going to do, I am going to configure a trunk by using dynamic mode. So let's configure the dynamic trunking protocol. Okay, for that let's go to the configuration terminal. Let's go to the interface FA0/7. Okay, similarly like that, switch port mode. Okay, earlier we have assigned this as a switch port mode trunk, right? Let's check this out. What are the available? Access, dynamic and trunk. Okay, so let's go to the dynamic, because today this time we are going to assign dynamic. What are the modes? I have already show you in the PPTs that auto and desirable two modes are there. Okay, if I have to set to the auto, then this neighbor switch also has to be set in the auto. Okay, and if in the desirable mode, then also neighbor switch can be either in desirable or either can be auto mode. Okay, so now let's configure this as a desirable. Okay, as you can see, the link has become up. Once it goes down, then next it become up. Okay, now and save the configuration. Okay, now let's go to the switch 2. Here let's go to the configuration terminal. Configuration terminal. Let's go to the interface FA0/5. Okay, here let's go to the switch port switch switch port mode switch port mode desirable dynamic, right? Dynamic, we are going to use dynamic which mode? Desirable mode. So desirable mode, both are in the desirable mode. So now the trunk will gonna form dynamically. So this is called DTP. Now let's check this out. Let's take this PC. Okay, let's ping from 10.0.0.10. Okay, let's try this. You can see that link is not up yet. Okay, so it is taking time, so that's why this packet has become lost, because the dynamic trunking has not formed yet. Okay, once it become formed, then it will go up. Okay, let's check it again once again. Okay, now you can see that the communication happens smoothly. Okay, even if you want to check one more time, let's go to the PC, this PC. Okay, let's try this ping 10.0.0 dot, let's say 9. Okay, see, as you can see, the connection is okay. So we can say, like here the trunking thing, there are many security issues. Like if I connect another switch in that area, suppose let's take another switch. Okay, another switch, let's take another switch and connect to any of the switch. Okay, or connect in between the trunk. Okay, and if I set this switch as a dynamic desirable also, or dynamic auto also, then what will happen, all the VLAN databases will automatically come to this database. And if this switch is a hacker switch, okay, if someone who try to that manipulate your network, okay, then it will be very difficulty, it might cause a lot of problem to the network. Okay, and security issues will be there. To avoid this kind of security, there are many encapsulation methods. You can go and check out in the switch. Okay, so as we can see that we have discussed about the DTP, dynamic trunking protocol. Dynamic trunk is negotiable is done using dynamic trunking protocol. DTP frames travel over the native VLAN. Okay, so native VLAN is used for DTP. Let's go to the next slide. This is called VTP pruning. So VTP, we have already discussed about VTP, different types of VTP, VTP server, transparent, client, right? VTP server, transparent, client, all these things we have already discussed. But VTP pruning is one of the technique where we use VTP pruning in the configuration terminal. Okay, you can configure it by yourself. Okay, VTP pruning is a certain technique. Suppose this server has VLAN 10, VLAN 20. Okay, but in the network, there are other switches also. Let's say this switch 2 is transparent mode. Let's say switch 3 in client mode. Okay, but this switch 3 requires only VLAN 20. So there is no need to send VLAN 10 to the switch 3, right? And in this switch, second switch, we can say that there is a need of VLAN 10 only, not the two. VLAN 20 is not required. So in that case scenario, what we can configure, how we can configure, we can configure VTP pruning, so that unnecessary flow of VLAN database can be prevented. So this is called VTP pruning. So this is basically all about uh, today's video's topic, that is VLAN, VTP, DTP. Okay, and how a switch is work, what are the L2 and multi-layer switches. Okay, here is the some question. You can try it by yourself. Just pause the video, try it by yourself. We are going to discuss on this, on about these questions in the next session. Thank you. Thank you everyone.